Welcome back. Another video. I'm pretty excited about it. Okay, so we're still talking about C, and today we're going to talk about recursion versus iteration. And I might go into some secure C programming. I don't know. If this one goes a little too far or a little too long, I might not. Well, what is recursion and what is iteration? Well, let's code it so we can find out. Firstly, I think we all know what iteration is, but for the most part, let's make an iterative loop, shall we? We'll make one that, is not that big of a deal, okay? So let's say, int equals, and we'll just make it simple, yeah? Okay, so we have an array, and it holds those values. Let's just print this array to make sure that it's working the way it should. I can't print an array unless I use my iteration. So, let's write the iteration, shall we? I didn't mean to do that. Sorry. So, I'm going to write a for loop. So, let's say for int I equals 0. I is less than... Give me 1 second. One second. Alright, so instead of making this modular, let's just say 4. So while I is less than 4, 0, 1, 2, 3, 4. I is less than 5. Alright, while I is less than 5, I plus plus, and then we're going to make our body. So what's going to be in the body? We'll just print some stuff, shall we? Print. And we'll say all right, so what should happen is that this array should print this number is, and then each number should be printed. That's what should happen. So let's test it. Don't run. What did I do wrong? Oh, print F. Silly me. Syntax errors, the bane of my existence. The number is 1, the number is 4. Let's put a line break there, new line. Let's try that again, shall we? There we go. The number is 1, the number is 2, the number is 3, the number 4 is the number 5, and bazanga sauce, we are donezo. This is an iterative loop. So let's go over what just happened. We created the integer array here, and we gave it some integers. And then we said, for integer I equals 0, meaning I initialized the variable I as an integer and assigned 0 to it. I then said, while I is less than 5, because there are 5 elements in here, so and everything starts at 0, 0, 1, 2, 3, 4, and I told the for loop to start our index at 0. Therefore, while it's less than 5, I want you to do whatever is in this body. And then at the end of the iteration, I want you to increment the I by 1. And so it works just fine. And what an iterator does, or a iterative loop does, is it iterates through something until it's finished. It's very fast, it's very efficient, and it does exactly what it's supposed to do. In other videos, I talk about do whiles and while loops. Those are also iterative loops. Just understand that it is best practice, if you want to iterate through something, to do iterative loops. Period. All right. Let's say I wanted to kind of do this differently. Let's say I wanted to, or not do this differently. I wanted to make a recursive function. Let's go ahead and write a recursive function. I'll write it right here. I'll just make another function here. We'll call it int factorial. Now I'm using a example from the website tech differences, http.techdifferences.com, and this is their example, so I want to use it because it's actually a very good one. So int factorial int num, and then I'm going to write the function. So let's make an integer and name it answer. Then I want to create a decision structure, and what the decision structure is supposed to do is supposed to ask if the num or the num parameter, if the argument passed to the num parameter equals a specific number. So if num is assigned the value of 1, then I want you to return 1. Else answer equals factorial num minus 1 times num. Now, what's going to happen here? Well, it's very simple actually. What's going to happen is when this function is called, it's going to ask for a parameter as an argument. It needs a value to the integer num that it has in its parameter fields. Then it's going to run the function body. And in the function body, we have int answer as a variable. And then we're asking a question to the computer. Check the variable num, the parameter num, the argument that is in the parameter num, and I want you to see if it's 1. If it is, return 1 and we're done. That's it. No more. However, if it's not 1, or else, if it's anything else, it doesn't matter what's in num. It could be a string. It can be anything. But if it's not the number 1, then I want you to assign to the variable answer factorial num minus 1 times num. What is that? What is factorial num minus 1? It is a call to the function factorial. Where is the function factorial? There's only one function named factorial, is there not? It's the one that we're writing, the one that I'm talking about. Recursive calls means that I am literally calling within the statement of the function, within the body of the function, I'm calling the function itself. So if I call factorial num minus 1 here, what is going to happen? Well, what's going to happen is that factorial is going to run all over again. It's never going to end until num equals 1. Now, there are certain situations where this is needed. Sometimes I use recursive functions myself because it's just the best way to do things. But recursive functions are not best practice, and in most situations they're frowned upon. Don't use recursive functions if you don't have to. Remember that recursion is always applied to functions. It's not applied to variables or anything else, meaning that when you call the function within itself, you're basically creating a loop that doesn't exist in the grand scheme of things. You're creating your own version of a loop. So when factorial num minus 1 fires, it's going to call factorial all over again, but num is going to be minus 1. This num, this parameter that's passed, is going to be minus 1 times num, which is going to be whatever that is. So if this was 3, well, let's actually run it and let's see what happens. So I want to comment all this out. Or actually, I don't need it, to be honest. Well, I'm going to save it just for you guys, I guess. I'll comment it out. And I'm going to call factorial. And I'm going to give it a number. Let's give it the number 4. And then I'm going to say printf factorial 4. Let's see what happens. What blew up? Ah, yes. I do this a lot. I write in so many languages that I forget syntax. Oh, crap. Yes, I know. Stop. Please. Okay, cool. Start. Is it going to throw an error again? Nope. It ran. 24, eh? Why did I get 24, 3, 4, 12, 24? Let me see something. Actually, that's the correct answer now that I think about it. Because factorial num minus 1 times num is going to return answer. And if I did factorial num minus 1 over and over and over and over and over again, it should be recursive in that it'll keep giving me a higher answer. But if I returned 1, if I said 1, then it should just give me 1. Yep. What if I said 2? Now, and I do the calculations in my head. Huh. Right. Because, and I'm just walking through it in my head right now. Else, because it's not 1, it's not going to run the return 1. What's going to happen is it's going to run the else. And then it's going to say answer equals factorial num minus 1, which is 1, by the way, times num. Factorial num minus 1 is going to return 1 here. Times 2 is going to be 2. If I said factorial 3, and let's do the calculations together, shall we? It's going to be 6. Why is it 6? Well, it's not 1, so it's going to answer equals factorial num minus 1. Factorial num minus 1 is 2 times 2, which is 4. So this is going to be 4. And then num is 3. That doesn't make any sense. It's going to be 2, actually. It will be 2. Ah, the confusion exists. All right, I get it now. So factorial num minus 1 is going to run this function all over again and give me answer. And what is essentially going to happen is it's going to keep multiplying on itself recursively. So where does this 6 come from? Let's walk through it very slowly. It took me a while to kind of grasp it. So factorial, we passed it the integer 3. Then we said integer answer, if it num equals 1, return 1, but it's not 1, so answer equals factorial num minus 1, which is actually going to give me another number altogether, times num. Num is 3. That's what I fed it, 3. So num is 3. This num is also 3. So 3 minus 1 is 2. Factorial 2, meaning that this is going to run all over again, so hold those values in your head for a second. Come back through with 2. All right, it's not gonna hit this if statement. It's gonna come back down here. So factorial 2 minus 1 is 1. So this is always gonna be 1. So that doesn't matter. Times 2, 1 times 2 is 2. So this is gonna be 2 in the first iteration. I know I went iteration, iteration, iteration. I'm doing 3 iterations. So 2 times 3 equals 6. Don't ask. I actually can write that out. Let's write it out, just so that it all makes sense. All right. So I add, how many times is this going to iterate? It's going to iterate the amount of times it needs to get to 1. So if I did 12, it's going to iterate 11 times. I only did 3, so it's going to iterate 3 times. The first time it iterates, we'll just say 1. The first time it iterates, answer equals factorial num minus 1, which is going to be calculated in the next iteration. So let's just leave that blank for a second. Times what the num is in the first iteration. The num in the first iteration is 3. All right, now let's go to the second iteration because we didn't calculate what that was. So factorial num minus 1 basically means 2 because 2 minus 1 is, 3 minus 1 is 2. So now we run factorial again. This is the second iteration of factorial using recursion. Answer equals factorial, once again, factorial num minus 1, or minus 2 is 1. So we're going to leave that open because it hasn't been calculated yet, times 2. Well, we know what this one is now because the answer for this is actually 2. Because this one is 1. Because in the third iteration, answer equals 1 because num equals 1. Because in the third iteration, num minus 2 minus 1, or num minus 1, is going to be 1. Therefore, this is 1. Therefore, we don't care about this because the answer of this one is going to go here. And the answer of this one, this answer is going to go here. Because we're returning answer out of the function. So answer, whatever that is going to go into each of these recursive iterations. Now, if that was not confusing, and if that doesn't make you not want to use recursion, then I will give you one more reason why recursion is bad unless you absolutely have to use it. and that's recursion is extremely slow. As cumbersome as this was for us to calculate by hand, this is equally as cumbersome to the computer. So, in the end, iteration is greater than recursion. But, for the most part, this is what recursion is. Now, secure C programming, let's just dive a little deeply into that for a second, because I want you to know there's another reason why recursion is not all that great. Recursion in and of itself does not take into consideration that you are calling the same function over and over again. And what that essentially can do is offer someone who has malintent to enter in while those recursive loops are occurring, because they're not actually iterative or a part of the value. Another thing about secure coding in C is that you'll run into situations where in C you can actually manipulate things at the memory level. For the most part, you do not want to do that. You don't even want to remotely start trying to manipulate things at the memory level. What do I mean by that? Remember when I got that error here and it told me that a memory location wasn't signed and I couldn't use that memory location because it wasn't defined and I wasn't... Well, I can actually override that error by saying, no, I do want to use that memory location and tell it to put it there. But in doing that, what I'm doing is I'm not letting my random access memory be dynamic. The CPU is normally random in where it puts its values in the random access memory or in the RAM. If I myself devise to the computer that I wanted to put it in a specific place, what I'm doing is I'm putting all my eggs in one basket. Bad, Francis. Second thing about secure programming in C that you want to know is that when you're doing something in C, it's important to understand what buffers you have and how you're manipulating those buffers. How do you keep your buffers clean? Well, first off, remember what I talked about in the last video about storage classes. If you have variables that never, ever, ever die, what does that do for your program? It opens it up to being manipulated because those variables are not dynamic. They're not created and destroyed as you develop. Things should not be static in your program. Things should not exist just to exist. And moreover, you should shy away as much as you can from global variables. Global variables are the easiest in for most hackers. Third thing about secure programming that you should know. You never pass parameters by reference. Always pass parameters by value. What do I mean by that? Give me 1 second. So, what do I mean by parameters by reference? That means that, and I apologize, looking at my notes. What that essentially means is that you're using the same variable in your code, or in the function that's calling the argument, the parameter, as the parameter. When I call this, so I'm calling factorial and I use 3. This is not a parameter, this is an argument. But what I could do is I could say that I want to pass x to the parameter x. This is called pass by reference. And what you actually want to do is you actually don't want to do that. If you're going to pass something by reference, what you want to do is you want to create two different variables of two different, not static, two different variables in two different localities in your classes that do not have the same name. What that essentially does is it does not link the functions together in the minds of someone who's looking at your code trying to emulate what you're doing or inject themselves into what you're doing. Now, passing by reference is something that I do all the time, and it's actually not that bad. It's when you pass by reference with functions that, or with variables that have not been renamed into something else or whatever the case may be, it makes your code that much easier to manipulate. Well, I hope that was, and I know there's people out there who will write in the chat and say that I'm wrong and I'm looking at this glass half full. Listen, this is my opinion and the opinions of a lot of other developers. So, if you like this video, hit the like button at the bottom, and if you like to see more videos like this, don't forget to subscribe. I'm Dr. Dev, and I hope you guys have a good one. Ciao.